This is lesson 2.8, part 2. This is going to be covering solving absolute value equations and inequalities. We have 2 learning targets that this lesson looks at. First, let's look at what absolute value means. The absolute value of a number is that number's distance from 0 on a number line. So what is the absolute value of -6? If -6 is right here, 0 is right here, what is that distance from 0 to -6? That distance is 2, 4, 6. Now, when you take the absolute value of a number, you always get a positive answer because absolute value, again, is a distance, and specifically the distance from 0. The symbol for absolute value is these two little straight bars on either side of the number. So whatever is inside those bars, it's asking you to find the distance that that number is from 0. So for example, absolute value of -9 is asking you the distance, how far is 9 from 0, or -9 from 0? It is 9 units away from 0. Here, if you add a coefficient or a product on the outside here, first do what's inside. You treat these like parentheses, kind of like if you're doing order of operations. So take care of the absolute value first. So the absolute value of 7. So 7 is 7 units from 0. So this is really just -2 times 7, which is -14. Here, if you're adding two absolute values, again, order of operations, do what's inside of the grouping symbols first. Absolute value bars are grouping symbols. Absolute value of -3 is 3 units from 0. Absolute value of 2, 2 is 2 units from 0, so this is just 3 plus 2, which is 5. Sometimes you may see a negative outside of the absolute value. Well, again, we're going to start inside of the absolute value. This negative on the outside stays on the outside, and then the absolute value of -12 is just 12. So your answer here is actually -12 because of that negative on the outside. If you have subtraction or addition inside the absolute value, do that first. So 14 minus 20 is -6. So this is really the absolute value of -6. -6 is 6 units away from 0. So that answer is just 6. All right, now how does this apply to equations and inequalities? Well, we have a couple of different options here for you to look at. These are on your formula sheet as well, so make sure you keep that handy. So write it in your notes and keep it handy with your formula sheet. If you're dealing with an equation, so in this first table, if the absolute value of some expression or variable equals some number, let's say a, then x, that expression inside, is going to equal a or -a. So what that's saying is whatever is inside this absolute value can be positive or negative, but it has to be equal to a positive number when it's written up here. So as long as its absolute value of x equals +a, then to solve that, you'll take that and say x is equal to +a or x is equal to -a. So for example here, the absolute value of x is equal to 4. So that means x can equal 4 or x can equal -4. And that's because +4, this question here is asking what numbers are 4 units from 0. Well, 4 and -4 are both 4 units from 0. All right, now what happens if we start bringing in inequality symbols? That changes things a little bit. If you bring in the inequality symbol, the absolute value of something that's less than a means that we're going to write an inequality that is and. So x is less than a and x is greater than -a. So if it stays a positive, for the part that stays positive a, you keep the symbol the same direction. The one that is negative a, you flip the inequality symbol around. Kind of like when you would divide or multiply by negatives to solve, you have to flip that around. This same rule applies to when the absolute value of x is less than or equal to a. You just use the less than or equal to symbol instead. Okay, now it's a little different if we have the absolute value of x is greater than a. If the absolute value of x is greater than a, then that expression inside is either greater than a or less than negative a. And then that same thing goes for if your symbol starts out as greater than or equal to. So your clues in which you're going to have to pay attention to are if it's absolute value and you're starting with a less than or equal to symbol, you're going to have an and statement. If you have absolute value greater than or equal to, you're going to have an or statement. All right, so keep these handy while you start practicing these until you get a little more used to them. All right, so let's start with something just basic. Absolute value of x is less than 4. Since we have a less than symbol, I'm going to write it as x is less than 4 and x is greater than negative 4. So x is less than 4 and x is greater than negative 4. Now, with these and statements, you can write them in an alternative way. This is a compound inequality, but we can also say, okay, since x is greater than negative 4 and less than 4, we can write it as being in between those two values, like this. So you can write it as x less than 4 and x greater than negative 4, or you can write it as x is between negative 4 and 4. It's the same thing. They are equivalent statements. Now to graph this on a number line, well, x is less than 4, open circle, x is greater than negative 4, open circle at negative 4, and then greater than 4, or greater than negative 4, less than 4. That means you graph that in between those two things. And that shows then why you can write this as this single compound inequality as well as with the and in between. All right, next, the absolute value of x is greater than 4. Well, since we have a greater than symbol, we're going to use or. So x is greater than 4 or x is less than negative 4. Now with or, they're going to be going in opposite directions. You'll see on the number line here in a second. So you're just going to leave them as an or. You can't write them as a single compound. So x is greater than 4. So open circle at 4, arrow to the right. X is less than negative 4. Open circle at negative 4, arrow to the left. So that's how we graph those absolute value inequalities. All right, let's solve some equations. So as you're solving these, pay attention. Is there an equal sign? Is there a greater than or a less than sign? So for these equality statements, the actual equations, we don't need to worry about graphing them on a number line. So solving these is going to be like if you have an absolute value symbol, it's going to be like dealing with parentheses or grouping symbols. You have to get rid of the stuff that's around those first. So we're going to subtract 1 from both sides here, and we get the absolute value of x minus 4 equals 9. Now, once we have this, let's go back up here. We have absolute value of something equal to a number. So that means it's going to be this something that's inside is going to be equal to that or equal to negative that. So this is going to be x minus 4 equals 9 or x minus 4 equals negative 9. And then you just solve both of those equations. So we add 4 to both sides and we get x equals 13, or add 4 to both sides over here, x equals negative 5. So you'll get two solutions with these, x equals 13 or x equals negative 5 for that one. All right, number 7. Similarly, let's get rid of what's outside of those absolute value symbols first. So add 3 to both sides. Absolute value of 2x equals 15. All right, now we're going to take this absolute value and we got to split it into 2 now. So 2x will equal 15, or 2x will equal negative 15. So if we divide both sides by 2, we get x equals 15 halves, or divide both sides by 2 over here, x equals negative 15 halves. And you can leave your answer written as such. All right, number 8. 4 times the absolute value of x plus 3 equals negative 16. Again, we have to get rid of everything that is on the outside of the absolute value first before we can start evaluating this. So we're going to divide everything by 4. Now the difference between absolute value and parentheses is that we can't distribute into absolute value. So we're going to, if you have anything on the outside of that absolute value, you have to divide by that first. So absolute value of x plus 3 equals negative 4. All right, now this is interesting. Didn't we say absolute value of something represents a distance? So it should be positive. So they're telling us the absolute value of x plus 3. So they're saying x plus 3 is negative 4 units away from 0. Distances cannot be negative. So if you have the absolute value of something, it cannot be equal to a negative number over here. So this is an example of an absolute value equation that would have no solution. All right, now 9, 10, and 11, we're getting into our inequalities. So we're going to have to remember, is it going to be and, or is it going to be or? So let's look at number 9. This is greater than. I'm looking at greater than. This is going to be an or. So 3x plus 6 is going to be greater than 12, or 3x plus 6 is going to be less than negative 12. And so we don't get confused there, I'll add that line. All right. Now from here, you've already studied in previous lesson how to solve inequalities. So we're going to do that the same way. Subtract 6 from both sides. 3x is greater than 18, and then divide by 3. So x is greater than 6. And then we have to do it again over here. Subtract 6. 3x is less than negative 18. Divide by 3. So x is less than negative 6. And we had the or in between, so we're going to bring that down here. So x is greater than 6, or x is less than negative 6. And then we have to graph, since it's an inequality, we graph that on the number line. So 6 is going to have an open circle, and we're looking at values greater than that. So we're going to go to the right. All right, and then negative 6 is going to have an open circle as well, and then x is less than, so anything less than negative 6, so we're going to the left. Okay, so graphing those or statements, they should look like this. Number 10, absolute value of 2x minus 1 divided by 2 is less than or equal to 1. Now, before we can start dealing with if this is going to be an and or an or statement, we have to isolate that absolute value expression. So we're going to start by multiplying both sides by 2. So multiply by 2, you get absolute value of 2x minus 1 is less than or equal to 2. From here, we have a less than or equal to symbol. Less than or equal to means we're going to have an and statement. So 2x minus 1 is less than or equal to 2, and 2x minus 1 is greater than or equal to negative 2. And then we have to solve both of those equations. So add 1 to both sides. 2x is less than or equal to 3, divide by 2. X is less than or equal to 3/2. All right, same thing over here. Add 1 to both sides. 2x is greater than or equal to -1. Divide everything by 2. X is greater than or equal to -1/2. Now this is an and statement, so let's just draw this out. So x is less than or equal to 3/2. 3/2 is about 1.5, so we're looking somewhere between 1 and 2. It's a closed circle, all right? And that goes to the left because it's less than or equal to. And then at -1/2, which would be somewhere about here, we have another closed circle, and that's greater than, so that's going to the right. So those overlap somewhere here in the middle, so remember that and statement is going to go in between those two values. So that's how you would graph number 10. Oops, and when you write this, make sure you write the and in there. Don't let me forget that. All right, number 11. So on number 11, first, you're going to want to isolate the absolute value expression. So we're going to subtract 23 from both sides. And we get the absolute value of 5x is greater than -10. All right, so this is a greater than. So if we go up here, that is going to be an or statement. So we're going to say 5x is greater than -10, or 5x is less than +10. Because remember, once you switch to the opposite symbol, switch to positive, you have to turn around that inequality symbol there. All right, if we solve this, divide both sides by 5. So x is greater than -2, or divide this one by 5. X is less than +2. All right, so this one, it helps to look at the graph to see what's going on. So x is greater than -2, so open circle at -2, going to the right. Then x is less than 2, so open circle at 2, going to the left. Now, if you look, really any real number is going to be able to fulfill this situation. So this whole number line is being covered by this or statement. So the answer to this type of an inequality problem is going to be all real numbers. All right, so if it ends up overlapping across that whole number line, all real numbers. And kind of a hint to see here is you can really see it in this spot right here. This is an absolute value greater than a negative number, and that's when you're going to end up with this whole number line being covered. So all real numbers are going to be in your solution set.